Hello there and welcome to another video. This one's going to be on section 8.2, modeling systems. And a lot of the questions that we're going to see in this lesson, they're kind of like word problem or applied type questions. So they can be a little bit more difficult, but as long as you kind of follow what we do in these questions and kind of use the tips, they aren't actually that bad. So it says, if a situation involves quantities that change at constant rates, and anything that changes at a constant rate, we got some different examples, like if you got paid so many dollars per hour, that's a constant rate. If you were going so many kilometers per hour, if you were walking maybe so many meters per second, those are all constant rates. So you can represent it using a system of linear equations. So basically you can make some equations, you might need more than one, that's why we have a system, that just means more than one linear equation. Next it says if you know the initial values and the rates, like these, you can write the equations in slope-intercept form. So slope-intercept form, if you remember, was y equals mx plus b. It was called slope-intercept form because it had a slope, that was the m, and then it had a y-intercept, that was the b. So if we want to put it into this slope-intercept form, what we need to do is whatever the rate is, that is going to go where m is, so that's the slope. And then whatever the initial value you get, that is the y-intercept. It's where you start at. So maybe if you started at like the 10 meter mark, this would be at 10 meters. And then maybe your rate was you were going 2 meters per second. Then you'd have in here 2. And then you could get your entire equation by plugging in the 2 and the 10. So some tips that we can follow to make this a little easier on ourselves is the first one, assign variables that relate to the problem. So some examples of these, like for time, use the letter T, for height you could use H, and for distance you could use D. Sometimes you might not want to use those letters, like in the examples below we're going to be using our calculator, so sometimes it's best to use X and Y because our calculator only uses X and Y. Our second tip though is use a diagram and or table of values, and we're going to do this on our first example. A diagram you could use like if you had someone like walking or a pool filling or something like that, just use that to help yourself, it'll make it a little easier. So our first example, it says people can rent ski equipment from two places. So the first option charges a one-time $30 fee and then $8 per hour, while option B charges no fee but they charge $14 an hour. So they charge more per hour, but they have no fee. The other guys have an instant $30 fee. So what we're going to do is we're going to come up with a system. We're going to come up with an equation for option A and option B. So for option A, first we're going to write it out a little bit simpler, and then we're going to kind of change it a little bit. So for option A, we're going to have a cost. And our cost is going to be from the $30 fee that we had. So I'm going to write $30 fee. Plus, we were going to get charged $8 per hour. So I'm going to put $8 per hour. And this would depend on how many hours we have. So we'd have to multiply by our number of hours. The more hours we use it, the more we got to pay. So if I would change this, maybe I change cost, I use the letter C instead. And then my $30 fee, well that's just 30 bucks. So I'm just going to put 30. And then I had 8. And that was being multiplied by our number of hours, and for my number of hours I'm just going to use T. It's going to kind of represent my time, the number of hours that have occurred. So I'm just going to rewrite this a little bit neater. I'm going to write C equals, and I'm actually going to put this part here first. So 8 times T, that's just 8T, and then I had the 30, so I got plus 30. So that would be my equation for the option A. My option B, it's going to be really similar now that I have that one. So it has no initial fee, so I don't even need like a plus something at the end, but it does have a $14 an hour rate. So that's going to go like where this one had an 8, but this one's going to be 14. So it's going to be 14 times T, and then if you wanted, you could put plus 0 more dollars, but you wouldn't have to. You could just keep it as 14T. So those two boxed equations, those would represent our system. Next we are going to solve the system, and we're going to actually use a table of values for this. So I have made a table of values for option A and a table of values for option B. And then my column headings, I have a T. T is going to represent time, so after 0 hours, 1 hour, and so on. and then the C just represents my cost, so how much it cost me for each one of those hours. So starting with option A, we knew that it was going to be $30 right off the start, $30 fee, and then adding on $8 per hour. So if I had 0 hours, it's only going to cost me $30 just right off the bat. As soon as I use it for an hour, I'm going to have $8 being added on. So it's now going to be 38. So to get from that one to that one, all I did was add 8. And then if I used it for another hour, I would have to add another 8. So this is going to get me to 46, and then I'll continue down. I'll just keep adding 8. So I get 54 for after 3 hours, and then after 4 hours you get 62, and then after 5 hours you get to 70. So this could just keep going and going. I'm just going to stop there, and then we're going to look at option B. So for option B, that one had no initial fee, so after 0 hours I'm still going to be at $0. But then for every hour that I had, it was going to be $14. So it's going to have to add on $14. So then I'll be at 14, and then add on another 14. So I'll be at 28. And then this is just going to continue down. So next I'll be at 42. So $42. And then add another 14. I'll be at 56. And then add another 14, and I get to 70. So we notice now this one has 5 and 70, and this one has 5 and 70. So both of them have the exact same 2 points. So I just boxed those 2 points. Those points represent our solution. Because it's the same in both of the tables, that is our solution. So I'm just going to write here, solution, it's 5 and 70. Now in the next part, it actually asks us, what does the solution represent? So that solution, the 5, remember the 5 that was in the time, and then the 70 that was in the C that was for cost. So it's saying after 5 hours, my cost is at 70. Same with the other one. After 5 hours, my cost is 70. So for both of our options, option A and option B, both of them cost $70 after 5 hours. So I'm just going to write something like that. But 0.5 and 70 represents that after renting for 5 hours, the price is the same for both options, which is $70. Our second example here deals with 2 pools draining at different rates. So it says 2 pools are draining at the same time. The larger pool contains 54,675 liters of water and drains at a rate of 25 liters per minute. And the smaller pool contains 35,400 liters of water and drains at a constant rate of 10 liters per minute. So the smaller pool drains more slowly, and the larger pool drains a lot quicker. So what I've done first is I've said let x equals the number of minutes passed, because that's going to be really important, the number of minutes. And then I said y is going to be my volume of water, because that's also going to be important because we were given volume right there. So in part A, we're first going to model the draining of the 2 pools using a system. So coming up with 2 equations. So again, I'm going to make an equation for the large pool and then also for the smaller pool. So let's do the larger pool first. So that one, we're going to have our volume. It's going to be equal to, we're going to start at 54,675, and then we're going to be losing water. So we're going to minus off 25 liters for every minute. So we're going to have to times by however many minutes we have. And we actually used the letter X for that. So I'm just going to change in my letters. Volume is Y. And then I'm actually going to put this part first. So I have minus 25 and then times by minutes, but I'm going to change the minutes into what we called it. It was an X. And then we had that plus 54,675. Now for my small pool, it's going to be really similar. So my volume is going to be equal to, our rate is 10 liters per minute, but we're losing it, so it's minus 10 liters per minute, so times by the number of minutes, and then plus our initial number was 35,400 liters, so 35,400 liters goes there at the end. So those 2 equations there represent our system. Now for this one, part B, it says solve the system and describe what it means. So for this one, we're actually going to use our calculator to solve it. And to use our calculator, we have to be able to know how to enter stuff in and then also how to find where the crossing or intersection point is. So I'm going to pull out my calculator here, and then we are going to first type in these 2 functions. So maybe just put it over here. So we'll turn our calculator on, go into y equals, and then we're going to put these ones in. It doesn't matter the order, you can put this one first or this one first. So it's negative 25, again reminder, you got to use negative, you can't use minus, so negative 25, and then x is right up here, and then plus this 54,000 number, so 54675. And then click enter, you can go down to the second one, and then put this one in, so negative 10x plus 35,400. And now that I have that, when I click graph, so it's got these dots here like it's graphing, but I get no picture. So I can't see where these lines cross, and if you can't see where they cross, you won't be able to find the solution. So we have to change our window or the picture that we just got. So to do that, we have to think about the numbers that we were given here. So with this one, the largest number that we had for the y is 54,675. So when I am going to change my window, it has to be more than that because that is big and we need to be bigger. This one is less than this one, so we don't have to worry about this one. Just look for the largest one. So I'm going to go into my window and I'll show you guys what we're given. So x, remember x we said, it's kind of hidden in behind here. It was the number of minutes that passed. So the number of minutes that we could have, we could start at 0 minutes. So I'm going to put in 0. Can't have anything less than that. And then our x max, our number of minutes, we're just going to put something in large here. I'm going to put in 2,500. If it wasn't big enough, you could just put in something bigger after, but that's a lot of minutes. And then our x scale, you can just leave it as 1. And then our y min, remember our y, it dealt with the volume. So we can't have anything less than 0. So I'm just going to put in 0. That's the lowest amount of volume I could have. Then for our y max, remember this was the largest number that we were going to have, the 54,000 number. So I'm going to go just a little bit more than that. I'm going to do 55,000 liters. Okay, and now when I click graph, I can see my one line, and then there's my second line, my second pool. So this line here is my larger pool, and then this line here is my smaller pool, because this is smaller, start with less water. This one's larger, start with more water. And I can see they both get down to this point right here. So I want to find that point, and to do that you click second, trace, and then this gets us to our options. So number 5 is intersect, so we want to find where they cross. And then you can click enter, enter, enter. As long as you only have 2 lines on there, it'll find where they cross. So we get 1,285 and 22,550. So I'm just going to write up on our screen there the window that we chose. So that was that right there. And then our solution that we actually just got was that right there, 1,285 and 22,550. So what that actually means is that after 1,285 minutes, both of the pools will have that much water left. So again, looking at the graph, this one starts with more water, comes down. This one starts at less water, but it's losing less per minute, so then they eventually cross right there. Okay, so that one's all done. We can look at number 3 here next. This one's going to deal with ticket sales for a movie. So it says a movie theater charges $11 for an adult ticket and $8 for a child ticket. So I know the number of adults and the number of children is going to be important. So I already said X is going to be for my adults and Y is going to be for my students. Then it says suppose 240 people attend a show and the ticket sales totaled $2,370. So part A, model the system of linear equations. So there's going to be 2 things that are going to be important with this question. The people that come, so the total number of people is 240, and then our total ticket sales is at 2,370. So I'm going to come up with 2 equations, one dealing with people, one dealing with ticket sales. So for people, I know that if I take my adults and my students and I add them together, I got to get 240. So if I take my adults, which I called X, and I add them with my students, I called them Y, that has to add up to give me 240 people. So there's one equation. My ticket sales, I know that it's $11 for an adult ticket and $8 for a child ticket. So if you only had, say, 2 children come to the show, it'd be $8 and $8, you'd make $16. Okay, so you got to take the cost of the ticket, $8, and times by how many you had. So if you had 4 people, it'd be 4 times 8, you made $32. So I'm going to go $8 times the number of child tickets, so that was Y, plus we also have our adult tickets, so that is $11 times however many adults we have, so X. And when I add up all of that money that I just made, it has to add to $2,370. So that is my second equation. So part B now says how many adults and students attended the show. So we got to use these two equations and solve to figure out what X is, how many adults came, and what Y is, how many students came. So to do this graphically, we have to get it into Y equals. So I'm just going to write that, get into Y equals, because that's the only way I can enter it in my calculator. I'll show you right here. If I go to Y equals, I can only type in Y equals and then the rest of the stuff. So I'm going to change these into Y equals. So here are our two beginning equations. Now I'm going to start on the left one. So to get the Y by itself, I just got to subtract an X, subtract an X. Those X's will cancel, and I have Y equals 240 minus X. For the one on the right here, I got to get this Y by itself, so I'm going to first get rid of this 11X. So I am going to subtract 11X, and then subtract 11X. The 11X's will cancel on this side, and then I just have 8Y equals 2,370 minus 11x, and then we got to get rid of this 8 here, so I'm gonna divide by 8, and got to do that on the other side as well. So divide by 8, these 8's will cancel, and I get Y equals, and on the other side we can just keep what we have, 2,370 divided by 8. If you wanted, you could reduce the fractions, but it's not necessary because we're going to put it into our calculator anyway. So we got those two equations right there. So those are what we are going to graph. So we're going to graph both of those. So let's go to our calculator next, and we're going to type those in. So we'll pull this out. We can delete what we had, so you can click clear, go on to the other one, click clear, and then we'll type this one in first. So 240 and then minus x. Click equals, and then go to our second one, and we can type this in. So 2370 divided by 8, and then minus 11x over 8. And now I'll click graph, and so it's graphing, it's got our dots going here, but again we get no picture, and this is because it was set up for the last question. So again we're going to have to change our window. So I'm going to click window, and then we're going to have to change these values. Now remember, our x dealt with, it's kind of hiding right here, the number of adults. So the lowest number of adults that you could have is 0. So that would be fine to keep that as 0. We can go to the next one. So x max, so the max amount of adults. Well, I knew there were 240 people total, so I know that the max amount of adults there could be would be 240. So I'll just change this to 240. And then my x scale can just stay as 1. Y min, so y deals with the number of students. So the lowest number, the minimum amount of students, can be 0. And then the max amount of students, again, there's only 240 people, so the max can be 240. And then y scale can stay the same. So we can click graph now. And we got our two lines. So I see that they intersect right here. So we can find that. We can click second trace. Number 5 is intersect. And then as long as you only have two lines on here, you can click enter, enter, enter. And we get x is 150 and y equals 90. So just on my page here, I'm going to put up the window values. So those were the window values that we used. And then for our solution, we're just going to write this down. So on our page, our solution was, it was 150 and 90. So remember, we had said that x was our number of adults and y was students. And our points, it goes x and then y. So this is our number of adults, and the 90, that is our number of students. So I'm just going to write that over on the side. So that is our solution. And that was also our last question. So our textbook questions are just down here at the bottom. We got page 440.